Okay, so good morning. Good morning to everybody. Welcome to Florence and welcome to Thales Italia. Okay, as you know, the presentation and the demonstration will be in a mixed formula. So we have speaker from here in Florence in presence and a speaker in remote side. I am the engineering manager of the project, and so I organize the engineering work during the 2 years of the project, and now I will present the agenda with the speaker and so this is the agenda. So the welcome, and then Marco Merlini, that is the project manager for Thales Italia side, will present Filip Krobosiski, if is here with us in call conference, and that is the project manager of Palaemon, so can introduce something about the project, the overall project. Then we have Gianluca Mandò and the Professor Marco Luise, that are the design authority, the people that had the idea of VDES in the time. So this is important to understand why VDES. Okay, then Mirko Frasconi, that here, will present for you some technical detail, so a technical overview, and some dissemination activity that we had. For example, he had gone to a NATO training center in order to anticipate, and he had presented this development to this NATO training center. Then we will have from remote side David Gomez from Athos. David Gomez is important this pitching because this demonstration is not a standalone demonstration. We have a connection to Spain. In Spain, there is the platform of Palaemon, so we can see in our PC, but we are connected with David. We can see the connection between the platform, the integrated platform, central platform. Then other technical interview. So there is Andrea Morelli from Wiser for the waveform. So also this is an important speech, and the gateway part application, the VDES gateway application. The last presentation is from Francesco Piantini. That is the interface between ECT, so the platform, and our VDES implementation. So this is a module for the interface.
So today we are about to conclude the activities that we have carried out for years and which have led to the creation of the prototypes that you will see in operation today later. The project focused on making the maritime transport safer, even in the worst scenarios. And the consortium is made up of many partners, including Airbus, which managed the project, and Athos, which led the development of ICT parts and other. Thales' contribution, as you know, concerned the development of the VDES system.
So the project started 40 months ago, and the project is a little bit holistic for the safety part of a ship. So we are covering several phases. First, we have tools that are giving decision support in order to know what is the status of the ship, if there is the ship can continue or if there is a need to evacuate. So if the decision is taken to evacuate the ship, there is a suite of tools, a large number.
why VDES is so important for us, for this project, and for maritime communication in general. It's a short recap about this. Coming back to the the origin of VDES, we cannot skip to speak about AIS. AIS is a success story, very success story. It was introduced in 2002, and it was initially conceived for collision avoidance. It is declared mandatory for safety of life at sea, SOLAS vessels that are vessels with a tonnage, gross tonnage greater than 500. It is an explicit reference to safeguarding human life. It seems that the origin is coming from Titanic, so at the beginning of the previous century. So it's a very long story, but what is the issue? The issue is that AIS is becoming overloaded and the channel are starting to be saturated. So this is due also to the fact that it's expanding its range, and the AIS channels are becoming overloaded. And AIS is considered a key element for future e-navigation solutions. So when e-navigation will be very spread, the issues regarding the overloading of AIS will become even greater. So AIS is not able to manage all of this. We need something different because this is the situation today. You can see the level of crowding that is in several areas worldwide. You see that we need maritime communication, we need broadband communication, we need to exchange information, not only positioning one, but also other kind of information between ship to ship, ship to shore, and using also satellite infrastructure for allowing the ships to communicate, even they are in the middle of the ocean. So VDES is the solution. This is at least the international view, the view that is growing in the international awareness, maritime awareness. It is the next digital communication system because it is from the beginning has been designed as a digital system. It is an efficient, robust, and global data exchange system. It's global because it encompasses, as it was in the AIS case, the satellite link. So you can really communicate wherever you are. It integrates this distinct communication system. So you are not losing AIS. You are englobating, you are integrating AIS. VDES VHF data exchange system is a communication system that integrates three different data channels. The first one is the famous AIS, automatic identification system. The second one is the application-specific messages. New messages has been defined to enlarge the type of information that can be transmitted from ships and from ships to shore. These are specific messages, I repeat. Then the third pillar is the VHF data exchange system, the wideband solution that I mentioned before. So this is today's situation for transmitting what? Mainly positioning information. This will become, and is in some areas worldwide, is already today under experimentation. This is the channel plan for VDES. A lot of the channels have been introduced, both for the ground and for the terrestrial and the satellite links. You can have the position, but I repeat, you can have specific messages. You can have wideband communication. You can send also videos, images from ship to other ships and to onshore. So it is really a jump. It is really a jump, a big improvement in terms of technology, in terms of capability of communicating. So it will be really a game changer, because you will be able to communicate worldwide, wherever the ship will be based, positioned, even in the open sea. You can see here in this picture that VDES will be the only one, apart HF communication, to guarantee the communication between the ships and the ground. The VDES is also the starting point, in my view, for e-navigation, because navigation will be the next step in improving the maritime communication, giving to the ships really the possibility to communicate not only the position, but also a lot of data about the ship, about the passengers, about the operators that are on board. It is a sort of global communication system that is been defined by International Maritime Organization, that has given some priorities. So it is a standard. It is very important for this reason. In Palaemon, we have implemented the prototype of the VDES solution. So it is a platform. We implemented a platform using COTS hardware, but developing together with Wiser. Thales Italy and Wiser has developed the waveform and ported the waveform of this on this COTS board. So we selected a couple of boards, one for the carrier, the other for the radio part. Has been selected with defining before requirements. So it is a really engineering process that we have followed. After that, we integrated from the hardware point of view, and then we installed it. We ported, it's better to say, because it was not an easy job. We ported the waveform from a PC implementation to a real embedded machine using an heterogeneous system of processors. So we are using CPUs, but we are using also FPGAs, and we have dedicated the radio capable for implementing the communication that we have, the modulation encoding system that we have implemented.
I would like only to add to what Gianluca has already said about the general purpose and the status of VDES, just a couple of news. The first is that in February this year, ITU published the whole standard about VDES. This is very good news, because until that time, VDES was developed and maintained by IALA. That's, let me say, a parallel organization not directly connected to telecommunications. While ITU is the international worldwide body dealing with communication standards. So the publication by ITU of the whole standard in February this year is a very good news, because it opens the avenue for further development of VDES. We have understood from VDES, from Gianluca, what VDES is. In modern parlance, it is an Internet of Things technology. It is a machine-to-machine communication technology. So it is very well integrated into a worldwide network for e-navigation, but not only. So much so that the European Space Agency has a precise roadmap for the development of satellite VDES. They are pushing very much toward this. The only problem that we have at the moment for the extension of VDES to satellite to give really global coverage of this technology is the definition and launch of a dedicated VDES payload. This is something that we will talk a little bit about towards the end of the meeting, because it is one of the possible avenues of development of the outcomes of Palaemon as far as VDES is concerned. The second good news is also the start of activity about giving VDES one more channel about ranging, so as to be able to perform autonomous positioning of the ship with yet another technology that is not satellite based, or okay, it may be satellite based, but it is not based on GPS, Galileo, on global navigation satellite systems. It can also be based on just terrestrial infrastructure, the shoreline stations of VDES. So that's one more channel. It is called VDES-R. It is something that, of course, we did not embed into our terminal because it is still in the phase of development.
We start saying what, in particular, what we have done for the Palaemon project. In fact, we didn't do just the VDES. We, in fact, had two packages for Palaemon. One is the definition of the authentication and encryption for all the software modules that are included in the Palaemon platform. And for doing this, we had a very good collaboration with Atos, the Aegean University, and ITML. As we will see, the VDES is interfaced with the Palaemon platform, and in particular, it exchanges information using Kafka. The other package, as we have already said, is the implementation of the VDES prototype. So in order to deploy this prototype, there was the SDR waveform generation developed by Wiser, so the software-defined radio. Then the development of the interface between the waveform and the hardware. Then another thing was the interface between FPGA module for turbo encoding and decoding and the waveform. Then everything has been ported onto the hardware, as Gianluca was anticipating. And then another important thing is the development of the VDES gateway application, that is the interface between the VDES and the Palaemon platform. And our colleague Francesco will explain how it works. So how the VDES works in the Palaemon ecosystem. In normal operation, the VDES will feed the Palaemon platform with data from coastal station, for example, weather or environmental condition, position monitoring, etc. But at the same time, the VDES software is subscribed to the notification from the Palaemon software module, allowing it to be aware of changes in the evacuation status. So it will be aware, for example, if we pass from a normal navigation status to an emergency status. In case of evacuation, the VDES transceiver can send a Mayday signal and some emergency messages to the shore and to other vessels. For example, the evacuation plan, passenger list, the ship waypoint, and so on. All information that can be useful for search and rescue operations. In fact, here we see what we have implemented in the lab for the demonstration. We will have 3 nodes because, in fact, we have developed 3 VDES nodes. One on the left is will be configured at power up. They are identical. All the nodes are identical. What changes is the configuration at power up that we can choose. So one will be configured as shore, VDES shore. The other will be configured as ship. They will be linked together with a radio link. We have the antennas. Each VDES is connected to a terminal running the VDES gateway application. The 2 terminals will be connected through internet to 2 important servers. One is the weather server that provides the weather information, and the other is the Kafka cluster. Then there is a 3rd node that is configured as AIS transmission. In fact, in order to synchronize the two nodes, we use an AIS signal transmitted over the air. For generating this AIS signal, we have captured and recorded a real AIS signal in the port of Livorno. So we made a dump of this signal, and we have a file that generates and reproduces this signal. In fact, we will see on the terminal that the system locates us in the port of Livorno. Okay, and in order to demonstrate the functionality, we will see three use cases. One use case is the AIS position instruction. So we will see that the signal produced by the AIS node is correctly acquired by the system. The second use case is the acquisition of the weather information. In fact, we will interrogate the weather service, the weather server, passing to it the AIS position that we have extracted at the previous use case, and it will provide us the weather information at that specific position. And we will pass this information to the ship. Then the third use case that we will see is a simulation of a status of emergency. So we will see that in case the evacuation status changes, the emergency status changes to a status of emergency, we will send an evacuation message from ship to shore, and then a Mayday signal periodically with relevant information, for example, the number of passengers, passengers list, the number of injured people, and so.
Yes. And a very last example that I wanted to give to connect this presentation with the, let's say, subsequent carried out by Francesco is how the, let's say, components are configured and work. In this case, all the components will hinge around Kafka, let's say the communication, let's say, and streaming services that will be responsible for transmitting and delivering the information to all the devices, where we will have, for instance, two different components. At the left, the Palaemon evacuation coordinator transmits and digitalizes all the evacuation shifts in the chain that we have seen before, and the VDES gateway that will be responsible after that for communicating to the VDES transceiver. Okay, so this is something that we will complement throughout the day. The way to do that is on Kafka, we, let's say, issue and sign tailored certificates for each of the components, one certificate per partner in this case, and we have a table defining the topics that every partner or component can write and read. In this case, we will, for this example, we will write on the evacuation coordinator topic, shifting, for instance, from normal status to situation assessment. And what this component will do is it will subscribe to this topic. Likewise, we do, for instance, in Twitter, we subscribe to a hashtag, and as soon as an event is generated, it will receive and process the generated event. Just to illustrate this, the JSON file is sent as on or tagged as evacuation coordinator topic. The message will flow around encrypted so that nobody else will be able to read what's inside the message, and then VDES will take and process and then pass to the next level.
This is the scheme of the transmitter. The modules are developed in C++, and under a multi-thread approach. So each module is a separate thread. This approach was followed in order to increase the flexibility of the radio and the scalability. So we have the information generator, and in this case we receive the data from the VDES gateway and format in order to transmit over the VDES channel, the turbo encoder. the modulator selected on the base of the quality of the channel, the shaping filter, the burst creation that include the ramp up power and the ramp down, and then training sequence. And okay, in this schema we have the USRP because in the first testing we used the USRP, but now we have the dedicated RF port to transmit on air.
First of all, I can show you first node of VDES. So this is our hardware, and here we can see the baseband board, the big one, and the RF front-end board, the small one. Here, under my pen, there is the CPU running the software, where all the software generation waveform has been. The first one will be configured as a shore station. The second node is exactly the same hardware and the same software. The only difference is that at power up, it will be configured as ship station. The two radios are connected to the antennas. So this is the transmission antenna of the shore station. And this is the receiving antenna of the shore station. Similarly, the ship station is connected to the transmitting antenna and receiving antenna. Here we see also the noise amplifiers that have been and show this one. This is the third node, as I said in the presentation, is exactly the same hardware as the other one. The only difference is that we have configured to generate the AIS signal that we have captured in the port, and is transmitting this signal to the other node through this antenna. As I said, as I anticipated, we will demonstrate the functionality in 3 use cases. The first use case will be the AIS signal position acquisition. The second use case is the acquisition of the weather information according to the position acquired in the first use case, and the transmission of the weather information from shore to ship. And the third use case will be transmission of an evacuation command from ship to shore and several mayday signals from ship to shore.
Okay, now the shore start to receive the IS messages from the IS lookup. So we have to wait one message from we have to wait the specific message from the shore lookup in order to synchronize the TDM. It's possible to see what we have on air on the admin. And here on the peak, we have the reception of the position from the assist. The last position is visible also on the map. Okay, so now we can switch on the VDES gateway on the short side. Okay. The VDES gateway received the ice positioning from the radio and send a request to the data server with the weather information. This is the response of the weather information, and it is sent to the radio, and the radio have already transmitted the data to the shore. To the ship. Sorry. Here we have the information received via radio. We have the message for case location, and here we have the weather info. And it is possible to see the weather info also on the ship PC.
This was the scenario we see before in the presentation. The IS radio sends the position, and the position is sent to the data vision bus in the shore and also in the ship. The weather data are required from the gateway and are sent to the data vision bus, as David can confirm to us, and to the ship, as we have seen in the log of the receiver radio in the ship. To perform the last test, the evacuation command test, we needed the assistance of David Gomes to generate an evacuation condition. After the generation of the evacuation condition, the VDES gateway on the ship side will start to send the Mayday messages. Operation mode, now the operation mode is 0. So at this moment, there is no evacuation condition. This is a normal condition. Operation mode, now the operation mode is 0. So at this moment, there is no evacuation condition. This is a normal condition.
And here we see the signal that has been transmitted on air.
Scenario.
The sending of the Mayday is when the evacuation status was set to 2 by David on the data vision bus. The evacuation command is sent to the shore, but especially there is a loop that every 2 minutes a Mayday message is generated by the gateway of the ship and received on the shore. Maybe we can ask David to show us the Mayday message received in the shore side.
Okay. So basically, I'm, let's say, entered let's say remotely through secure cell the virtual machine that represents the onboard infrastructure here. At this left side, what you are seeing is let's say the evacuation coordinator protocol. Let's say as soon as a voyage starts, it sends a resource recovery signal. All this heartbeat just to keep track of that all components are, let's say, up and running. You see here as VDES, the app, the gateway is responding. And here we see AIS positioning. So let me try to zoom in a little bit. We see as the messages are generated quite often. This is Francesco. I don't know why I have not received so far weather messages. Anyway, I think it's not a problem. Okay, and then the 2 Mayday messages that you have sent. So as soon as we have a new timeout, yet another one will be sent. Okay, so this is oh, look, the weather message is there. Just matching what you have sent in your through your transceiver. Let me paste this in the chat just as a kind of proof, and then pretty much the same on Mayday messages. According to the explanation we saw before, if you remember, using the certificates, Thales certificates had the rights to subscribe to all the evacuation coordinator based messages, and they had the right to write on AIS position message, weather service, and Mayday. And we are using a kind of, let me say, God mode, and we are able to subscribe to every single piece of communication in the project. So that's why we are able to see and display here all the different messages. Okay, I hope this is enough proof to check that your system works, guys. So from my side, really happy to. I think we have had a lot of fun with this. It was, and again, congratulations with all the tough work that you have, let's say, carried out.